All right. So in yesterday's class, we had learned about what is meant by atomic orbital, what is meant by molecular orbital, and what is meant by linear combination of atomic orbitals. And we have taken hydrogen as an example, and we have seen how atomic orbitals are combined to form molecular orbitals. What are the two molecular orbitals? One is bonding molecular orbital, and another one is anti-bonding molecular orbital. Okay, so then we had continued our class and we have learned the what is meant by how molecular orbitals are formed in molecules. Okay, so here in this slide, we have what we are seeing is an example of molecular orbital energy level diagram. Okay, this is an example of a molecular orbital energy level diagram. What we are seeing here is, and we are able to see here on this x-axis, this is nothing but energy. So this is an increasing energy. 1s is lower energy, 2s is higher energy, and 2p is more higher energy. Okay, so here 1s and 1s is atomic orbitals are combining. 1s and 1s atomic orbitals are combining, and they are giving sigma 1s and sigma star 1s. Okay, 2s and 2s atomic orbitals are combining and they are giving sigma 2s and sigma star 2s. 2p and 2p atomic orbitals, they are combining and they are giving sigma 2p, okay, pi 2p, 2 pi 2p orbitals, then pi star 2p orbitals, then sigma star 2p orbitals. Okay, then we will go to our next slide. Okay, so in this next slide, we are it talks about, this slide talks about the electronic configuration of nitrogen molecule. Okay, electronic configuration of nitrogen molecule. This is the electronic configuration of nitrogen molecule. Okay, nitrogen atom is having 7. Okay, atomic number 7. Nitrogen atom is having atomic number 7, and its electronic configuration is 1s2, 2s2, 2p3. Now, why we are studying? You can ask, why are we seeing this electronic configuration of nitrogen atom? This electronic configuration we are seeing because we have to study about nitrogen molecule. Okay, nitrogen molecule, we have to read, we have to study about nitrogen molecule energy level diagram, molecular orbital energy level diagram. Yesterday, I told you that it will come for 5 marks. Okay, so in that question, we have to write the electronic configuration of a nitrogen atom. We have to start by writing the electronic configuration of nitrogen atom. Okay, so we had studied the electronic configuration of nitrogen atom. And now this is the molecular orbital energy level diagram of nitrogen. Okay, so here we are able to see, so 2 nitrogen atoms here are combining to form nitrogen molecule. 2 nitrogen atoms are combining to form nitrogen molecule. Now here we can see that 1s and 1s, 1s and 1s, what are these 1s and 1s? Atomic orbitals. They are combining to form sigma 1s and sigma star 1s. 2s and 2s atomic orbitals are combining to form sigma 2s and sigma star 2s. 2p atomic orbitals are combining to form sigma 2p, pi 2p. Actually, this sigma 2p should be down and pi 2p should be up. But in case of nitrogen molecule, pi 2p will be down and sigma 2p will be up. Okay, that's an important thing. Okay, in nitrogen molecular orbital energy level diagram, when we are writing, this 1s and 2s will be same for nitrogen, oxygen, and fluorine. But for nitrogen, there is a difference here. The pi 2p will be down and sigma 2p will be up. Here pi 2p will be down and sigma 2p will be up. Okay, this is what we have to remember. This is what we have to remember here. And electrons, Here 1s, 2 electrons, here another nitrogen, 2 electrons. Total 4 electrons are filled up like this. Here 2s, 2 electrons and 2s, 2 electrons. The total number of 4 electrons are filled up like this, sigma 2s and sigma star 2s. And 2p, total number of electrons, 3 plus 3 of 2 nitrogen atoms are filled up, 6 electrons are filled up in bonding molecular orbitals. Okay. Now, what is the bond order? We have to learn what is meant by bond order. Okay, bond order. What is now? So we have seen what is the electronic configuration of nitrogen atom, and we have seen, we have studied what is the electronic configuration. What is the electronic configuration of what is the molecular orbital diagram of nitrogen molecule? Okay, pi to p is down and sigma to p is up. Pi to p is down, sigma to p is up. Okay, now we will see what is the bond order. Bond order is nothing but number of electrons that are present in bonding molecular orbitals minus number of electrons in anti-bonding molecular orbitals divided by 2. Okay, this is the formula, bond order formula, very simple formula. Number of electrons in bonding molecular orbitals, number of electrons in anti-bonding molecular orbitals divided by 2. Now, in bonding molecular orbitals, how many electrons are there? See how many electrons are there in bonding molecular orbitals. You can see here. How many electrons are there in bonding molecular orbitals? Here, start, we'll count from 1s. 1s we have bonding 2. 2s, 2 electrons, total 4. And in 2p, we are having a total number of 6 electrons. So 6 plus 4, 10 electrons are there. 10 electrons. 10 minus, here we have 2 plus 2, 4. Anti-bonding 4 electrons are there. So 10 minus 4 by 2 is nothing but 3. Okay. So bond order is nothing but 10 minus 4 divided by 2, which is nothing but 6 divided by 2, which is nothing but 3. What does bond order indicate? Bond order indicate the number of bonds that are present between 2 nitrogen atoms. Okay, nitrogen atom has 2 nitrogen atoms are bonded by 3 bonds. Okay, 1 sigma bond and another 2 are 2 pi bonds. Okay, 2 pi bonds. Okay. Now, this is nothing but bond order. Now, we will see what is magnetic property. Okay, magnetic property. Magnetic property means if there are any unpaired electrons, then the molecule is magnetically active. If there are no unpaired electrons, then molecule is not magnetically active. Okay, very important. Magnetic property. See here, all electrons are paired here. Okay, all electrons are paired here. So all electrons are paired here, and there are no unpaired electrons. There are no unpaired electrons. Very important. There are no unpaired electrons present in nitrogen molecule. So this is diamagnetic. Okay, very important. Diamagnetic. Means diamagnetic means it indicates that the molecule has no magnetic property. Okay, since there are no unpaired electrons present in nitrogen molecule, it is diamagnetic. Okay. We will go to next slide. Now we will study what is the molecular energy level diagram of oxygen. Okay. So in order to study the molecular orbital energy level diagram of oxygen, we have to see what is the electronic configuration of oxygen. See here, we are able to see the electronic configuration of oxygen. Very simple electronic configuration: 1s2, 2s2, and 2p4. Okay, 1s2, 2s2, and 2p4. Okay, so oxygen. Now let us see what is the electronic configuration of nitrogen. Nitrogen has 2p3, 1s2, 2s2, and 2p3. Oxygen has 1 electron extra, and it is nothing but 2p4. Okay. Now let us see what is the molecular orbital energy level diagram. Okay. So molecular orbital energy level diagram of oxygen. Molecular orbital energy level diagram of oxygen. This is oxygen. This is oxygen. Okay. So here 1s is there, 1s is there. 1s is both combining. 1s and 1s is both combining. 1s and 1s is both combining and giving sigma 1s and sigma star 1s. 2s is both combining and it is giving sigma 2s and sigma star 2s. 2p and 2p is both is combining to give sigma 2p, pi 2p, pi star 2p and sigma 2p. So here what we have to remember is in case of nitrogen, pi 2p is down and sigma 2p is up. But here in oxygen it is reverse. Okay, sigma 2p is down and pi 2p is up. Okay, that is what we have to remember. Sigma 2p is down and pi 2p is up. See how electrons are filled up. 1s is there, 4 electrons. 2 electrons are here bonding and another 2 electrons are anti-bonding. Okay. Now 2s and 2s electrons are there like this, and 2s electrons here, and another 2 out of 4, 2 are here, another 2 electrons are here, sigma 2s. Okay, so total number of electrons of 2s, 4 electrons are filled up like this. Now in 2p, we can see here in 2p that we have how many electrons here? 4 plus 4 electrons are there. 4 plus 4 electrons are there, and the total number of 8 electrons have to be filled up. Now here 2 electrons are already filled up. Here 2 electrons are filled up, and 1 electron is filled up here. Then another electron is filled up here. Then 1 more electron here, and then another electron is coming here. Okay, so total number completed is 6 here. Okay, but here we have 4 plus 4, 8 here. So out of 8, 6 are completed and 2 more are there. Okay, so 2 more will be filled up like this. Okay, equally filled up. So equal energy, we saw that Ohm's rule, according to Ohm's rule, equal energy orbitals are there. So equally filled up. Understood? Equal energy orbitals are there and they are equally filled up. Now see 2p and 2p is there. 2p is here. 2p. Okay, 2p has 4 plus 4, 8 electrons. So out of 8 electrons, 2 electrons are consumed here, sigma 2p, and another 4 electrons are filled up. How they are filled up? First 1 electron here, then second electron here, then third electron here, then fourth electron here. Okay, so total electrons consumed is 6 electrons. So out of 8, 6 are consumed. Another 2 electrons, 1 electron here and another electron here. Okay, so total number of electrons filled up are 8 electrons. Now bond order. Now we see bond order. Okay, bond order. We have to study bond order. So what we are studying in bond order, see what we are studying in bond order. Nb minus Na means number of bonding electrons minus number of anti-bonding electrons divided by 2. So let us count the number of bonding electrons and anti-bonding electrons. So here bonding 2 plus 2, 4 electrons, 4 plus 6, total 10 electrons are there. Okay, total 10 electrons are there. And now let us count in anti-bonding. Let us count in anti-bonding. Now here we are having a 2. Okay, plus 2. Anti-bonding, we are counting anti-bonding. 2 plus 2, we are having total 4 electrons plus 2 electrons. 4 plus 2, 6 electrons. So number of bonding 10 electrons minus 6 electrons are there. 2 plus 2 to 4, 5, 6. 10 minus 6 is nothing but 10 minus 6 is nothing but 4. So 4 in numerator divided by 2 in denominator is nothing but 2 2s are 4. Okay, 2 is there. What is meant by this bond order is equal to 2? Bond order is equal to 2 indicates that the number of bonds between two oxygen atoms, number of bonds between two oxygen atoms is 2. Okay, number of bonds between two oxygen atoms is 2. Okay, its oxygen is a diatom. It's a diatomic molecule with two bonds, bond order 2, meaning two bonds are there between two oxygen atoms. In case of nitrogen, we got 10 minus we got 8 minus 2, okay, by 2, 6 by 2, 3. We got bond order 3 in case of a nitrogen molecule. But in case of oxygen, bond order is 2, meaning two bonds are there for oxygen molecule. Okay, nitrogen, just remember, we got bond order 3. For oxygen, we are getting bond order 2. Okay. All right. Now, magnetic property. Magnetic property. So what is meant by magnetic property? Means for magnetic property, we have to see like this here, diagram we have to see. And here we are able to see that there are unpaired electrons. See here, there are two paired electrons. These are two paired electrons. These are paired electrons. All these are paired electrons, but these are two unpaired electrons. Okay. So these two unpaired electrons are there. Unpaired electrons are there. And these two unpaired electrons present in oxygen molecule, it is paramagnetic. Okay. Meaning oxygen molecule exhibits magnetic nature, magnetic property, and that's why this is called paramagnetic. Okay, since there are total two unpaired electrons present in oxygen molecule, it is paramagnetic. Okay. So now let us go to the next slide. So in this slide, we are able to see the electronic configuration of fluorine. Okay, fluorine, the atomic number is 9. Okay. So nitrogen is 7. Okay, nitrogen is 7, oxygen is 8, fluorine is 9 atomic number. Okay, please remember that atomic numbers of nitrogen, oxygen, and fluorine. Nitrogen is 7, oxygen is 8, fluorine is 9. Okay, 9 atomic number, fluorine 9 atomic number. Now, fluorine is 9 atomic number. How they are distributed? 1s2, 2s2, and 2p5. They are distributed like this. Electrons are distributed 1s2, 2s2, and 2p5. Very important. So we have to remember this electronic configuration. In case of nitrogen, it is a 2p3. In case of oxygen, it is 2p4. In case of fluorine, it is 2p5. Okay, 2p5. Now, this is the molecular orbital energy level diagram of fluorine. Okay, energy level diagram of fluorine. Very easy. Okay, fluorine similar to nitrogen and oxygen. Okay, very simple and very easy. 5 marks question. Okay, 5 marks question. Mid semester or end semester, 5 marks question. This is okay. So electronic configuration, half mark. This is 2 marks. Electronic configuration 1 mark. Diagram is 2 marks. Bond order 1 mark. Magnetic property 1 mark. Total 5 marks. So molecular orbital energy level diagram of fluorine, F2. Now, one fluorine is there here, another fluorine is here. Okay, two fluorines are combining and atoms are combining to form fluorine molecule. Now, fluorine molecule is like this. Now, 1s of 1s is there like this. 1s is here like this. 1s and 1s, 2s and 2s. 2p and 2p. Okay, so now 1s and 1s is combining and forming sigma 1s and sigma star 1s. 2s and 2s is combining and forming sigma 2s and sigma star 2s. 2p is combining and forming sigma to px. Okay, sigma, then pi, then pi, then pi, then sigma, then sigma. Okay, in case of nitrogen, these two are down, this is up. Whereas in case of oxygen and fluorine, this is down and these two are up. Okay, very important point. Okay, we should write properly in exam in order to get full marks so that we can pass easily. Okay, so we are discussing about this molecular orbital energy level diagram of fluorine. So 1s is combining with 1s and it is forming sigma 1s and sigma star 1s. Okay, sigma 1s is there, sigma star 1s is there. Okay, sigma 1s is like this, sigma star 1s is like this. Okay, 2 electrons are filled up here, 2 electrons are filled up here. So total 4 electrons are completed. Now 2s and 2s, total 4 electrons, sigma 2s and sigma star 2s. Sigma 2s is 2 electrons filled up and sigma star 2s is another 2 electrons. Total 4 number of electrons are filled up and it is forming 1s molecular orbitals and 2s molecular orbitals. 2p atomic orbitals are combining and forming 2p molecular orbitals. Sigma 2px molecular orbital, pi 2, okay, then pi pi, then another pi pi, then last is sigma star 2p. Okay, sigma 2p, pi 2p, pi 2p, pi star 2p, pi star 2p, sigma star 2p. Okay, these are bonding, these are anti-bond. Now, total number of electrons are, let us count here, 2 plus 2, 4, 5 total number of electrons are there. So here another 5 total number of electrons are there. So 5 plus 5 total number of electrons. So total 10 electrons are there. Here 2 electrons, here 2 electrons are filled up, here 2 electrons are filled up. So 1 electron will go here, another electron will come here. Then one more electron will go here and another electron will come here. So the total number of electrons filled up is nothing but 2 plus 2 plus 2. So 6, 7, 8, 9, 10. 10 electrons are filled up. So let us cross check how 10 electrons are filled up. Here 2 to 4, 5. Here another 5. So total 5 plus 5, 10 electrons. So 2 plus 2 plus 2, total number of electrons are 6, 7, 8, 9, 10 electrons are filled up. Okay, that is the molecular orbital energy level diagram of fluorine. Now let us see the bond order here. Now let us see the bond order. Here we have to see the bond order. We have to see the bond order. Okay, number of electrons in bonding minus number of electrons in anti-bonding divided by 2. This is the formula for bond order. Okay, bond order indicates the number of bonds between the two fluorine atoms. Okay, so let us count the number of electrons in a bonding molecular orbital. Here let us count. So bonding 2 electrons plus 2 electrons, 4 electrons, 4 electrons plus this all is 6 electrons, 6, 4, 10. 10 electrons are there. Okay, so number of electrons in bonding molecular orbital is 10. And let us count the number of electrons in anti-bonding molecular orbital. So 2 electrons here, 2 electrons here, and 2 plus 2 electrons are here. Okay, so 2 electrons, 2 plus 2, 4 electrons, 5, 6 electrons, 7, 8 electrons are there. So let us see here, 10 minus 8, 10 minus 8 is nothing but 2. 2 divided by 2 is nothing but 2. 2 divided by 2 is nothing but 1. I am sorry, 2 divided by 2 is 1. Okay. Now here we have to see what is the magnetic property. We have to see what is the magnetic property. Magnetic property is nothing but whether if there are unpaired electrons, then the molecule is paramagnetic, means it exhibits magnetic property. If there are no unpaired electrons, then the molecule is non-magnetic, means it does not exhibit magnetic property, and hence it is called as diamagnetic. Now let us see here. Now here we are seeing that all are paired electrons here. Okay, all are paired electrons here, all are paired. So since there are no unpaired electrons, fluorine molecule is diamagnetic. Okay, so the molecule is diamagnetic here, and and here it is there are no unpaired electrons in diagram. We are very clearly seeing. So that is why this is no magnetic property, and this is diamagnetic. Okay, so this is the molecular orbital energy level diagram of fluorine. 5 marks question. Diagram should be clear, and the electrons filling should be proper, and this 2px is coming down, and pi 2p is coming above sigma 2p, and here it is same. Okay, we have to remember this part because it is changing for nitrogen, and oxygen and fluorine are same, but nitrogen is different. We have to remember that. And bond order, we have to remember bond order, and we have to write magnetic property. No unpaired electrons, and hence it is diamagnetic. So we will get 5 marks. Now here is a crystal field theory. Crystal field theory. Okay, next topic. So we have learned what is the atomic orbital. We have not learned what is a molecular orbital. We have learned what is meant by molecular orbital energy level diagrams. We have learned, and we have learned molecular orbital energy level diagram of nitrogen, oxygen, and fluorine molecules. We have learned how to draw the molecular orbital energy diagrams of all these molecules, and we have learned what is meant by bond order. We have learned what is meant by magnetic property. Okay, bond order, number of electrons in bonding minus number of electrons in antibonding by 2 formula. Okay, very important. And what is meant by magnetic property? Unpaired electrons, paramagnetic. No unpaired electrons, all are paired electrons, then it is diamagnetic. Okay, now we are going to another important topic in we are studying another important topic in crystal field theory. This is another important topic, crystal field theory. Okay, very important topic in our unit 1. Okay, unit 1, molecular structure and theories of bonding. Molecular structure means what is the structure of the molecule. Okay, based on molecular orbital energy level diagrams, we have seen what is the structure of the molecules. Okay, and the theories of bonding. Okay, what are the various theories of bonding that are present in a complex molecule? Okay, in a complex molecule. Now what we are seeing here is nothing but crystal field theory. Okay, very important, crystal field theory. Okay, crystal field theory. First point, crystal field theory considers that the central metal ion is surrounded by an electrical field. Okay, so central metal ion is there, and around central metal ion, electric field is there. Okay, central one metal ion is there, center. Okay, surrounding the central metal ion, electric field is there. Very important. Remember, central metal ion, electric field. 2 words. Remember, we will see what is it. Central metal ion is there, and surrounding central metal ion, there is electric field. Okay, now ligands may be negatively charged. Now that the electric field, what is electric field? Electric field is nothing but the atoms around the central metal ion. Okay, central metal ion is there, and surrounding the central metal ion, there are atoms. There are various atoms are there. Okay, the various atoms are neutral molecules. Negatively charged atoms are there, or neutral molecules are there. Okay, the neutral molecules are NH3 and H2O, but must donate a pair of electrons to the metal ion. Okay, nitrogen has lone pair of electron, oxygen has lone pair of electron in H2O, so they will donate the lone pair of electrons to the metal ion. So metal ion is there, and electric field is there. So metal ion is surrounded by electric field. That the surrounding electric field is nothing but the electric field caused by the negatively charged ligands like F minus, Cl minus, Cn minus, or neutral molecules like NH3 and H2. Okay. So, thus due to the electrons belonging to the central metal ion and their interaction with the ligand electrons, an electric field is developed. Okay, central metal ion is there. Surrounding central metal ion, electric field caused by the negatively charged ligands are there. Okay, now the electrons belonging to the central metal ion and their interaction with the ligand electrons, an electric field is developed. Okay, an electric field is developed. Now let us go to the next slide. So that electric field is developed, and depending upon the electric field, the orbitals, d orbitals are split into EG set of orbitals and T2G set of orbitals. Okay, depending upon the electric field, they are split into EG set of orbitals and T2G set of orbitals. Let us see what are EG set of orbitals and what are T2G set of orbitals. What we can see here in this slide is EG set of orbital is nothing but dz square and dx square minus y square, EG set of orbital. And T2G set of orbitals is nothing but dxy, dyz and dzx. Okay, these are EG set of orbitals, dz square, dx square minus y square and dz square. T2G set of orbitals, dxy, dyz and dzx. Okay, let us go to next slide. Okay. This slide talks about, depending upon the electric field, there is a grouping of d orbitals into EG set of orbitals and T2G set of orbitals. EG set of orbitals are dx square minus y square and dz square, and T2G set of orbitals are nothing but dxy, dyz and dzx orbitals. So this is called doubly degenerate set of orbitals because two equal energy orbitals are there. That's why they are called doubly degenerate set. And this is called as triply degenerate set of orbitals. EG orbitals are more concentrated on the axis, and the T2G orbitals are situated somewhat between the axis. Okay, in the next diagram we will see how EG set of orbitals, doubly degenerate orbitals, how they are more concentrated on the axis, and how T2G set of orbitals, how they are situated somewhat between the axis. So here are d orbitals. D orbitals, s orbital. In first slide we have seen s orbital is spherical, p orbital is dumbbell shape, and here we are seeing that d orbitals are double dumbbell shape. Okay, this is double dumbbell shape. Double dumbbell shape d orbitals are there. We are seeing here clearly. Only this is not proper double dumbbell, but rest all are double dumbbell shape. Okay, now shapes of d orbitals are double dumbbell shape. We are seeing double dumbbell shape, and which are concentrated on the axis, which are concentrated on the axis, and which are concentrated in between the axis. We have to see that. Which are concentrated on the axis? These are concentrated on the axis. X-axis, y-axis, concentrated on the axis. X-axis concentrated, y-axis concentrated. That's why this is called dx square minus y square. X-axis concentration, y-axis concentration is there. Dx square minus y square orbitals. dz square orbitals. dz square concentrated on z-axis, mainly concentrated on z-axis. Okay, that's why it is called as dz square. Now we will see dxy. Okay, this is x-axis, this is y-axis, and this orbital is present in between axis here. Okay, in between axis, in between x and y-axis. Okay, orbital is concentrated in between x and y-axis. Okay, now this is dxy. Okay, you have to see properly. Okay, dx square minus y square concentrated on axis, dz square concentrated on z axis, dxy concentrated in between x and y axis. Now dyz is also concentrated in between y and z axis. Okay, y axis is like